Hey, Mike from Prep Pros here, and today we're going to cover 10 things you're going to see on your December 2024 digital SAT. We're going to be pretty heavily focused on that second harder math module, and we're also going to talk about a few particularly tricky question types that have been showing up with increasing frequency this fall. The end of the video, I'm also going to talk about some of the resources that I've been using that have been helping my students score perfect or near perfect scores this fall, along with some recommendations I have for you to help you improve your score as quickly as possible heading into the December SAT. And we're going to talk about one exciting final update where if you need additional practice tests that are really reflective of the difficulty you're going to see on test day, where you can find some of those. Now, the first thing you're definitely going to see on your digital SAT are questions testing you on linear equations with no solutions, one solution, or infinite solutions. These have been really popular so far this fall. So we're going to start with this example, and then we're going to go to our systems of equations variation, then we're going to start digging into some of the really advanced question types. So here we see in the equation below, j and k are constants. If the equation has infinitely many solutions for x, what is the value of k? Well, what we want to understand, we're going to get to the graphical part for our next example in a minute, but infinite solutions just means everything is the same on both sides of the equation. If we were to graph these two sides of the equation, we'd have to see the exact same line because it's constantly intersecting, so we have infinite solutions. So what we can kind of think about here is our x terms have to be the same and our constants or numbers also have to be the same. So the first step here is let's distribute through that j. So we're going to get our jx minus jk is equal to 3/4 x plus 15. Well, from here we know everything has to be the same. So we now know, right, jx has to be equal to 3/4 x because our x terms have to be the same on both sides. These are only x terms. So therefore we know that j is equal to 3/4. Now we're going to get to our next part. Therefore, we know that our numbers or constants also have to be the same. So therefore, we need to also understand that negative jk is equal to 15. And this is why these questions are a little tricky because we have to kind of pick out the particular pieces we're setting equal to each other. Well, now we also know that j is 3/4. So we now know that negative 3/4 k is equal to 15. So now we can just divide out that negative 3/4. And that is going to give us that k is equal to negative 20, and there's going to be our correct answer. Now, building off what we just covered with that kind of more basic variation, we want to understand here, since we're saying one of the two equations in a system of linear equations given, the system has no solution, we want to understand that these are going to be parallel lines that are never going to intersect. So there's no reason to bother doing this by hand. We always want to do this variation in Desmos, and they show up a lot on the test, and they're super easy. All we have to do is essentially guess and check. So if we kind of start with b here, if we do 1/7 x equals 15y, well, here we can clearly see there's an intersection point. But if we go through and we check a, which will be our correct answer, we do x equals 15y. Once you see that these two lines are just parallel, it's going to give away your correct answer really, really easily for you. If we were looking for infinite solutions, C would be our correct answer, and you would just see both lines stack on top of each other, and you could turn one off, and you'd see the other one appear right underneath it. Gives you a super easy way of handling these questions. One of the things you're going to see on your December test are inscribed shapes questions. These have been showing up a ton on the digital SAT, and they're giving a ton of students a lot of trouble, but there's a few secrets we can kind of think about around these that makes our life a whole lot easier. So here we see a circle is inscribed in a square such that the circumference of the circle touches the midpoint of each side of the square. Just do your best to draw it out on test day. It doesn't have to be perfect. The length of the diagonal of the square is 256 units. What is the area in square units of the circle? Now, the kind of general secret to these questions when they're showing up in the SAT is they're almost always involving your special right triangles in some way, and you're given those in your reference sheet as well. What we want to recognize here is since we've done a diagonal of a square, we have created a 45, 45, 90 triangle, so we're going to have those proportions of x, x, and this diagonal is going to be x√2. Now, since we're looking for the area in square units of the circle, we need to figure out what the radius is. But what we also just want to remember here is if we're thinking about this circle being inscribed, the circumference goes all the way across the side lengths here, but that means the radius is going to be half of it. So the radius, in terms of what we're looking at here, is going to be equal to 1/2 of x after we've defined it with these special 45, 45, 90 triangles. So we just need to figure out what 1/2 of x is. Well, since we know 256 is equal to x√2, we're going to have to just start using these proportions to solve through. So we're going to say that 256 is equal to x√2. Therefore, we're going to divide both sides by √2. we're going to get that x is equal to 256 over root 2. Now we have to go ahead and rationalize it, and this is another reason the SAT likes these. If you start putting in your calculator, you usually are going to have some sort of rounding issue at the end. So now, if you don't keep all the numbers in there the whole time, now we're going to get this is equal to 256 root 2 over 2. That's going to give us that x is equal to 128 root 2, and therefore our radius, which we said was defined as 1/2 of x, is going to be equal to 64 root 2. Now we just have to do pi r squared, so we're simply doing pi and then 64 root 2 squared, and that's going to give us our correct answer here of B. Now, another thing that you're definitely going to see on your digital SAT are what we can think of as advanced unit conversion questions, and most of these have been centering around squared or cubed unit conversions, so we're going to talk about that one particular step. We've also seen quite a few questions of this really amped up difficulty where it's a lot of steps and students often get pretty tricked up. So we're going to break this all down. A rocket's speed is increasing at a rate of 14.6 meters per second squared. So I do 14.6 and we'll do meters. And then here, really important part, we want to take note of per is a code word for divided math. And since we're going to have our second squared, we need to square that unit. So we're going to have over 1, and I'm just going to do second squared. Now from here, what is the rate in miles per minute squared? Well, let's just go ahead and take care of our miles to meters conversion. And this is also going to be a good teaching moment for the first thing. So we're going to do 1 mile over 1,609 meters. Now your kind of first learning moment you always want to think about with unit conversion is you always need to be able to cross cancel your units properly. So we have the meters and meters, those are canceling up. That tells us we've set up this conversion factor properly. Now here we're going per minute squared. So we need to convert from seconds to minutes. Well, what we know is we know there's 60 seconds in 1 minute. And now is the part where we also want to make sure we're remembering this. If you ever see any sort of squared unit, you need to square your conversion factor. So we're going to have to do this because this is going to end up giving us 3,600 seconds squared per minute squared. And then we're just going to punch this all into our calculator. We're going to end up doing 14.6 times 3,600 divided by the 1,609. And that's going to give us our correct answer of 32.67. It's all in the setup. Just 2 important things to remember. Make sure your units are properly cross-canceling. And if you see squared units, you need to square the conversion factor. If you see cubed units, you need to cube that conversion factor. Now, the next thing you're going to see are what we can think of as interpreting constants questions, and more particularly, interpreting constants in exponential growth and decay, which feels super confusing. We're going to talk about 2 easy ways to figure these out. So here we see the functions f and g are defined by the equation shown where a and b are integer constants and a is greater than b is b and greater than 0. So we have integers and they're positive and a is greater than b. If y equals f of x and y equals g of x are graphed in the xy plane, which of the following equations displays as a constant or coefficient the maximum of the graph of the corresponding function when x is greater than or equal to 0? Well, since we're looking when x is greater than or equal to 0, and these are both decreasing exponential functions, if you aren't familiar with that part, we're going to talk about a simpler variation of exponential growth and decay later in the video, so we should hopefully clear that up. But these are decreasing, so the y-intercept when x is greater than or equal to 0 is going to be the maximum of the equation. So essentially what this is just saying is which one of these is showing our y-intercept is a constant or coefficient. Now, this constant or coefficient part still often feels super confusing for students. So we're going to go through kind of the technical way, then we're going to go through the Desmos way in a minute. What this means is when we're thinking about exponential growth and decay, this is our y-intercept, this is our rate of increase or decrease, this is our kind of time periods, and this would be showing us a shift. But if we're displaying as a constant or a coefficient the maximum or the y-intercept, it means we're looking for this b value to be the y-intercept. Now the way that we can technically solve through this by hand is that means we're looking for if f of 0 and g of 0 are both equal to b. If they are, that's going to show us the maximum. If not, it's not. So if we start with f of 0, we'd get that b times 0.97. Well, to the 0 plus a is just going to be to the a power, but this is not going to be equal to b because b times 0.97 to some positive value is not going to be equal to b, so 1 does not work. Now as we get to g, here we're going to have g of 0 is equal to b times 0.97, well, to the 0 plus a, Anything to the 0 is 1, but this means here that g of 0 is going to be equal to b plus a. So our y-intercept is not being displayed as a constant or a coefficient here, it's being displayed as constants. So this is where neither 1 nor 2 works. Now this is a super advanced question type, so we're going to jump over to Desmos and plug some numbers in, and this is hopefully going to make a whole lot more sense. Now if that more conceptual and technical way lost you a little bit, we're going to talk about how you can still solve these in Desmos very easily if we just remember that one basic concept that the b has to be showing us the maximum because that's what's going to be expressed as the constant or coefficient. So all I would do is just graph this. Now, I was super fancy here and I put in kind of our limits for x, but you could also just remove that and only look at the part of the x from the y-intercept over. But then we're just going to use a slider and we're going to set our values. So we just set it as 2 and 3 here because we're told that b is greater than 0 and a is greater than b. But now what we need to understand is we know to go back, if that maximum is being shown as a constant or coefficient, it means it needs to be equal to whatever the b value is. Well, b is 2, but if we go to f of x, our y-intercept or our maximum is 1.82535, so that's definitely not going to show it as the constant or coefficient. Now, as we go to g of x, we can see once again it's not equal to b, it's equal to b plus a, so it is not being shown as a constant or coefficients, it's being shown as constants. That's how we can tell that neither is correct in a little bit of a more comfortable way for a lot of students. Now, the next thing you're going to see on your SAT are scale factor questions, and these can show up in a whole lot of different varieties. We have some of the most advanced versions kind of in our advanced math course. We're going to start with a decently hard one here, but not an insanely hard one. There are two similar rectangles. The area of the larger rectangle is 9 times larger than the area of the smaller rectangle. The perimeter of the smaller rectangle is 44. What is the perimeter of the larger rectangle? Well, we have similar shapes, so this is a good indication we're dealing with a scale factor question. Now, your scale factor is just the multiple of the side lengths or the perimeter or the circumference of similar shapes. So what we kind of need to understand here is the relationship between our area multiple and our scale factor, because that's going to let us figure out what we need to multiply 44 by. Now, the common mistake is to multiply it by 9, but there's a little tricky thing that's happening here. So we're actually going to just kind of go to this table and we're going to work through with the actual numbers here. If we have a scale factor of 3, this means our perimeter is 3 times greater because our side lengths are 3 times greater. But the way that you can often remember this pretty easily for most students I work with is area and surface area are in squared units. So your area or surface area multiple is equal to your scale factor squared. So if our scale factor is 3, our area is going to be 3 squared or 9 times greater. Volume is in cubic units, so our volume multiple is going to be our scale factor cubed. So therefore, if we had a scale factor of 3 and this was a 3-dimensional object, our volume would be 27 times greater. So here, since we know our area multiple is 9, we'd want to take the square root of 9 because we have to work backwards to find our scale factor, which is going to give us 3. That's going to tell us our scale factor. Now we know the first one's perimeter is 44, so we simply can do 44 times 3, and that's going to give us our correct answer here. Now, the next thing you're going to see on your test is exponential growth and decay. Now, I know we looked at that super advanced version with interpreting constants earlier, but we're going to run back through a little more basic version and also touch on percent increase and decrease because these topics often intertwine. So whenever we're looking at the basics and understanding the equation, is we kind of were talking about that constants question earlier, the p value is always our starting or initial value or y-intercept. This is showing us the rate of growth or decrease or decay. It's always 1 plus the rate of growth or 1 minus the rate of decay. And this is going to be our time intervals. So now let's kind of put that into practice here. A model estimates that at the end of each year from 2017 to 2023, the number of mice in a population was 125% more than the number of mice at the end of the previous year. The model estimates that there were 450 mice in the population at the end of 2017, so that's going to be our starting value, so we need to see the 450 here, so that can get rid of C and D, because we were starting from the end of 2017, we're going to 2023. Which of the following equations represents this model where M is the estimated number of mice in the population, T years after the end of 2017, and T is less than or equal to 6. Well, we know we have to be starting at 450. Now, the other piece we always want to remember is we're always doing 1 plus or minus the rate. Well, here we're showing growth, so we have to be doing 450 times 1 plus 1.25 all to the t, and that's going to give us our answer of B. Now, Percentages have been showing up a good bit on the test, and one concept students sometimes struggle with is how to go from percent to number form. Easiest way to remember is if you're going from percent form to number form, you're going to divide by 100. So there's our 1.25. If we're going from number form back to percent form, you simply need to multiply that value by 100. That's going to give you a really good benchmark you can always use if you see any questions like this or basic percent increase decrease. Now, the next concept you're going to see is going to be tested in those conventions of standard English, and this is going to be misplaced modifiers. Now, these often feel really confusing to students, but they're very easy once we actually understand what we're looking for. Now, you're going to be able to spot modifiers because they're almost always going to be the longest type of answer choices you're going to see in conventions of standard English, and you'll also kind of see this modifier at the front of the sentence. So we're just going to read back through the whole passage. Johannes Kepler was a mathematician and physicist who not only observed, but also sought to explain the celestial dance above. Observing that the planets move in elliptical paths around the sun, here's our modifier. So our rule is whatever follows it has to come directly after that modifier. So you have to ask yourselves the question, who or what could be observing that the planets move in elliptical paths around the sun? Is it Kepler's first law? Well, a law can't be observing something. A year can't, but the person can. And that's how we can see that C is our correct answer. So long as you can spot these and ask yourself that question of who or what is this describing, you have to look at what's coming at the front of the answer choices. You should hopefully be able to pick these up on test day. Now, the next concept you're going to see on your digital SAT are sentence structure questions. These can show up 4 or 5 times in any given digital SAT, and they're really easy to improve. You just need to understand how to spot independent and dependent clauses and the rules around properly joining those. If you're not familiar with those terms and those rules, please check out the free trial to my Ultimate SAT course. You don't need a credit card. It's totally free. It's going to teach you all those basic rules and give you a lot of practice. It can really make a very quick and meaningful impact on your score. So we're going to take a look at this now. Most of the American population does not drink the recommended amount of water each day. Independent clause. When participants in a study were given smart water bottles that track their intake, dependent clause. Over 75% of the participants were able to consume at least the recommended quantity of water. Independent clause. Now, since we have independent up here and independent below, we have 2 full sentences. So we need to follow any of those rules for how we can join 2 independent clauses together. The only one that properly does those is C with a comma plus one of our fanboys. If you try to do these questions by ear, it's really common to miss them. So as I said, make sure you learn these rules. It can make a big impact in your score. We're going to talk about one final question type, and then I'm going to talk about some recommendations and resources you can use, whether you're just trying to focus on advanced math, cramming in the final week, whether you need more additional really challenging practice tests. So stick around for all of that here. So this is what we're going to call a tricky transition question. Now these are going to be pretty easy to spot because you're going to see transitions. They're going to be sandwiched between punctuation. Now, the first step that I always like to take for students is check the clauses before and after. So once again, if you aren't familiar with those clause rules, go to the free trial, learn those. It's going to make a big difference in your score. The Sahara Desert in Northern Africa is a subtropical desert. I'm going to always ignore the transitions when I'm checking the clauses. Well, this is independent. It is the 3rd largest desert in the world and makes up approximately 25% of Africa. Also an independent clause. So at this point, we can eliminate A and we can eliminate D because those aren't giving any of our 5 possible ways of joining 2 independent clauses together. Now from here, both the colon and the semicolon can, when the following sentence giving explanation, definition, clarification, a colon can be used. So now we really need to figure out whether we should be doing comma, transition, punctuation, or punctuation, transition, comma. And the easiest one to always check is this one in C. What this is essentially saying to you is you should be able to pop the for example right back here. And that means from the first sentence to the second sentence, if that's correct, the second sentence is giving an example of what's discussed in the first. If not, we should be able to leave it here, and the third sentence should be giving an example of our second sentence. So we'll always just start with, like I said, start with C, because more often than not, this is the right answer. Across Earth's biomes, there are 5 types of deserts: subtropical, coastal, rain shadow, interior, and polar. Now, right, we're going to pop the for example in right here. For example, the Sahara Desert in North Africa is a subtropical desert. Well, that makes perfect sense. We're giving an example of one of those types of deserts. That's how we can see that C is correct. If we were to try to check B, it makes no sense because this isn't giving an example of what's talked about here. We're continuing to talk about the same Sahara Desert, so that's how we can tell that C is correct. Now we're going to talk about a few recommendations depending on your scenario for how we can help you improve your score as quickly as possible heading into test day. So we're going to start with category number 1, which is going to be those of you who are cramming and probably haven't done as much SAT prep as you would like to have done, whether you're watching this video a week out, 2 weeks out, or a handful of days before your SAT. If that's the case for you, I strongly recommend checking out our SAT crash course. This is designed exactly for your situation. We're going to cover all of the topics that show up every single SAT and where we can make the quickest, most meaningful impact in your score so we can do it in the shortest period of time, and we're just going to focus on those super commonly tested concepts. Now, the second category is going to be for a lot of students, and this will kind of bleed into our third one a little bit as well, but for those of you who are just really struggling on that second harder math module. If that's the case for you, you want a lot more practice with some of those like really challenging questions we looked at earlier in the video, I strongly recommend checking out our advanced math course. It's been working wonders for students the entire time the digital SAT has been out. It's helped produce a ton of 800s, high 700s. We're really just going to be focusing on all those really advanced question types that if you haven't been exposed to, they're really hard to figure out on the fly on test day. Now our kind of final category is going to be for those of you who have used all of the Blue Book practice tests, or you just want some more comprehensive test prep, and you may have a bit more time over Thanksgiving break to dedicate to that. So if you've already worked through those 6 Blue Book practice tests, you may have heard that really, unfortunately, only test 6 is the only one that's really accurate to the difficulty you can see on test day. So as part of our Ultimate SAT course, we've now added 4 of our own practice tests that are at or beyond the difficulty of test 6 of Blue Book. These are really designed to be super reflective of the types of questions, including those super complex reading questions students have been seeing in the second module, more difficult grammar, more difficult vocab, really challenging second math modules. And it's been an essential piece for what helped a lot of the students that I've heard back from so far that have scored 15 plus on the SAT is having those really challenging practice tests to work through. For now, they're only available as part of our Ultimate SAT course, but we have 4 of those, and they're great practice for those of you who want really, really high scores. Additionally, if you sign up for the Ultimate SAT course, we're going to cover everything A to Z that you can see on your SAT, so especially if you have a little bit more time on your hands these final weeks and you're good to dedicate it, you can really use that to address all of the places that you're struggling with most to make really meaningful impacts. If you're already scoring in the 1400s, to help you kick up to the 1500s or beyond, it's going to be a fantastic resource to help you out. If you guys have any questions at all, drop them in the comments below on this video and I'll try my best to get back to you quickly. Otherwise, best of luck on test day.